Hello everyone, this is Group 9 and we are here to demonstrate our final project, which is the Action Rules Extraction program. This is the Eclipse IDE, and on the left hand side you see the source code structure of our project. It has 4 Java files. The invocation of this program starts with the main file, which this is the short source code. What we do over here is we instantiate the UI class to create a UI object, and we initialize it with the necessary parameters. The input data.java class basically deals with the input reading and the pre-processing, wherein we try and replace the unsupported values with a known value. The action rules class is where the meat of the processing happens, wherein we use the LERS algorithm to look for association rules, and we use the action rules ARAS algorithm to come up with the final action rules. So let's go ahead and run this program. You right click on the project, run as, and say Java application. This is the main UI. So our program basically works on 2 types of text file inputs. One is the attribute file, one is the data file. The attribute file should have attributes delimited by a space, and the data file should have its values delimited by a comma character. Let's go ahead and choose the attribute file. So right now I'll be testing this program on the LERS exercise dataset, which is a short dataset to demonstrate the program. Let's go ahead and choose the attribute file from this dataset. There we go. Now also choose the dataset. Let's set the minimum support for this operation to be 1 and the minimum confidence to be 10%. Go ahead and say load. So you see all the attributes have been loaded. Now we are supposed to be choosing the decision attribute. The decision attribute is the one which is going to change as a result of application of the action rule. The decision will be changed by looking at certain combinations of the independent variables, which are all the other variables other than the decision attribute. So let's go ahead and choose D as the decision attribute. Now we want the value of D to change from 2 to 1. Now all the other remaining attributes can be classified as either stable attributes or flexible attributes, and this option basically allows us to mark some of them as the stable attributes. The stable attributes would not undergo any change when you are coming up with the action rules, and only the flexible attributes will be allowed to be changed. So let's mark C with an index 3 as the stable attributes, and let's go ahead and say submit. So the program has completed and the entire log of the operation has been dumped into the text file. You see over here every loop wherein the certain rules and the possible rules along with the final action rule. This over here is the final action rule. If you look at it, this is what we wanted to achieve. D should have changed from D2 to D1. This has happened, and this is the particular action rule which says for D to change from D2 to D1, A has to change from A2 to A1, and C being stable did not go any change, but there is a condition that C has to remain at C1 and B can change from any of its value to B1. So this is one action rule that leads to change from D2 to D1. Similarly, there are 2 more action rules over here. Now let's go ahead and try this program again on the mammographic breast cancer dataset. Let's open the necessary attribute and data text files. Let's set the support to say 3 and the confidence to say 75%. Say load. The attributes have loaded. Now let's set the decision attribute to say age. Now I want to see what action rule can we come up with to make a change in the age from 30 to say 60 years, and let's set the density to be the stable attribute over here. So submit. The program has started calculating the action rules. Let's wait for a while. So while this program completes, I have to note that it is very necessary that the attribute file is delimited by spaces and the data file is delimited by comma, so otherwise the program may not work as expected. So there we have the final output. This is the entire log with each of the loops shown. We have the certain and possible rules for every iteration of the program here, and it also shows the action rule schemas calculated. So there you go, that was the demonstration of the action rule extraction program. Have a good day.